Chapter 20, Descriptive Statistics, page 1 and 2. We're going to go through some terms about statistics which you may know or you may have heard. Maybe you don't know exactly what the differences are between these, so bear with me while we go through these definitions from the book. What is the difference between a census and a sample? Well, if you remember from, well, maybe you're too young to do this, but every 10 years in Brazil and in America, they send out people to count the population and gather data about the population for that year. When they do that, it's called a census. And so basically, they're trying to talk to every single person in the country, if possible. Okay? And they do their best to do that. When you take a sample, you talk to just a portion of the people in the total populations. You can see I wrote that a census is a collection of information from the whole population. Sample is only from a randomly chosen subset of the population. Okay, so what happens if we don't choose our sample in a random manner? Okay, if you, for example, if you want data about EAC school and you only talk to your friends to figure out information about the whole school, that's not really random, right? It's that you ended up polling only your friends. So there's certain things that are common about you, so it's not really a good cross-section of who's in the school. So what's going to happen is you're going to get answers that are biased. Okay, so I wrote, you will get bias or strong tendencies not representative of the population. Okay. The process of collecting information from a sample is called survey. Give an example of where you see these being done. Well, like, how about at an election? After an election or before an election, sometimes they have surveys of people to see who they're going to vote for or who they did vote for so that they can figure out which candidate is leading. So I'd say like before or after elections. Okay. Information about individuals in a population is called data. Give an example of a categorical variable and a numerical variable. I put that a categorical variable for the EAC population would be Brazilian, American, and Korean nationalities. Numerical variable could be the age of the EAC population. A parameter is a numerical quantity measuring some aspect of a population, but its value is usually not exactly known. A statistic is a quantity calculated from sample data used to estimate that unknown value. Okay, so usually, like if you want to know the average height of someone at EAC, maybe you're going to not have time to measure every single person, so you're going to choose like a few people from each grade, and then you're going to measure just those people. And so the parameter you're measuring is height. It has some definite value, but it's too much trouble or it takes too much time to find it. So you're going to use a measurement of a sample of people, and you're going to calculate a statistic, the average height, using the sample data. So of course the statistical value that you calculate is just going to be an estimate of the real value, which nobody knows. Okay? The sketch of the distributions on the axes below have the following patterns of variation. So a symmetrical distribution would be any kind of distribution where the left side looks like the right side, kind of like, symmetrical like a parabola, some kind of graph which the left side is reflected over a axis of symmetry. Positively skewed means instead of, like, let's say you start out with a symmetrical distribution. So a positively skewed distribution is going to get pulled to the right. So instead of being centered, it's got like a big long tail on the left side. And negatively skewed would be the opposite. It's pulled to the negative side. Okay? So like instead of being nice and symmetrical, the positively skewed is pulled to the right, and negatively skewed is pulled to the left. Give 2 examples of discrete numerical variables. Okay, so this could be a good example for us is the IB exam grade, IB score, because there's only whole numbers between 1 and 7, right? Another example would be like your grade level that you have, like in the AC, like 7th grade or 8th grade. Give 2 examples of continuous numerical variables. So that would be something like your age, right? Your age is not like just the number of years. It's also, you know, it could be months, days, minutes, seconds to actually calculate your age. So your age is actually something that's kind of continuous. Another thing might be your weight. Your weight, it would vary according to the number of kilograms, grams, milligrams, etc. So basically, continuous numerical variables are like decimal numbers that go on almost forever, and discrete numerical variables only take on usually integer values. Could be certain decimal values, but they have to be like a specific number of decimal values. Okay, at the right, draw an example of data arranged in a frequency table with the columns value, tally, frequency, and percent relative frequency. So here I've drawn the top of the table, and now I'm going to extend the table down here. And I got the columns that they asked me to put in, value, tally, frequency, and percent relative frequency. And I'm going to use the example of IB grades. So we're going to have 1, 2, 3, 4, 5, 6, 7. And the way we usually make a table like this is we go through a list of scores, and then we just start marking with tally marks how many times we see each one of these. So, oh, I got 1 4, well, I got another 4, I got a 5, I got a 7, I got a 6, I got a 3, I got 2 2s, I got another 4, etc. So, you know, if you just keep these tally marks, you're going to eventually see that there's a certain number of each one. A lot of times you get a bump in the middle here. And so, and then like how do you get the frequency? Then you add up the tally marks. So you have 1, 2, 2, 4, 2, 2, 1, kind of like that, right? And then the percentage relative frequency, the way you calculate that is you would add up all these numbers here. So it would be 5 plus 4 is 9, 10, it would be 14. And then so to get the relative frequency, I would just take each one of the numbers in the frequency column divided by the total, which is 14, and then I would get a percentage, which is the relative frequency. So for example, 1 divided by 14 would be, 1 divided by 14 would be 7.1%, right? And then relative frequency, you would calculate for each one of these, what's the percentage for that IB score. So, for example, 2 divided by 14 would be 14.3%, and so you would put that wherever you have it. 2, right? 14.3%, 14.3%. This is also 14.3%. Okay, so that's basically what a frequency table looks like, and the ones you definitely are going to see, the columns you're definitely going to see are value and frequency, but sometimes you might see the tally column, and sometimes you might have the relative frequency column depending on what you're trying to get out of your table. What type of frequency graph is used for discrete numerical variables? That would be a column graph. What about for a continuous numerical variable? That would be a frequency histogram. And what you've used mostly up until now is the column graph. You used it for science fair. You've used it for a lot of different graphs you've done through your years. And the difference between column graph and frequency histogram is kind of what you would imagine. If you were going to graph a frequency graph for whole numbers and you were going to graph it for decimal numbers, it's a little bit different, right? So a column graph, let's say you're graphing the IB scores. So then basically you're going to have the IB scores written out across the bottom, and then you're going to have the frequency of each one of those, and it's just going to have a little bar above it showing how many people got each score. Okay, and in a column graph, what we see is we see the space in between each column. And when you do the same type of graph, but you do it for continuous variable, then sometimes what you do is you say, let's see, like GPAs. GPAs can range from 0 through 4, and they could be 3.5, they could be any number in between 0 and 1, 1 and 2, etc. So sometimes when we graph those, at least in IB, we graph them like this. And do you see how I'm putting the numbers, or the columns, like right next to each other? So now basically these columns show, okay, how many people have GPA between 0 and 1? And that would be this level here, maybe it's a 3. And then how many people have a GPA between 1 and 2? Let's say that that's like 5. Okay? And the big difference is, I'm labeling the border values like at the edges of the columns, and the columns are stuck together as a result. Okay, so that's kind of the difference between which one you do. So why is it easy to remember when to use each type of the graph? Well, I think it's easy to remember because for discrete or whole numbers, the columns are spaced apart, just like the numbers. So, I mean, to me, it kind of makes sense that the graphs are spaced apart, just like the numerical values. Okay, it's kind of hard to read that, isn't it? I'm going to put it up here. Okay. In a frequency histogram, what can you say about the widths of each column or class interval? What they're looking for there is, do you see how each class interval here is 0 to 1, 1 to 2, 2 to 3, 3 to 4. I'm making ranges, data ranges, to put each possible GPA in, like buckets, and each one of those buckets has a equal width. So I say it's equal. Okay. And how do you identify the modal class from looking at the frequency histogram? Well, the modal class is similar to the mode. The difference between a mode and a modal class is mode is like one value, and a modal class is like the bucket that has the most things in it. So you can see that the biggest, the most full bucket would be this one here, between 2 and 3. So I would say that the modal class in this case would be the tallest. Would be like the tallest column will indicate the modal class. Okay, let's move on to page 2. Page 2 has some problems. Frequency table for the heights of a basketball squad is given alongside. Explain why height is a continuous variable. Okay, I think height is a continuous variable because it can take on any decimal value, not just discrete values. Okay. What about B? Construct a frequency histogram for the data. The axes should be clearly marked and labeled, and the graph should have a title. Okay, we'll do that at the right. Let's see. So, okay. Let's see. So, but we're going to mark the x-axis with the heights, and then we're going to mark the y-axis with the frequencies. So here we're going to have 170, 175, 180, 185, 190, 195, 200, and 205 across the bottom, and that is heights in centimeters. And then on the y-axis, we're going to mark the frequencies, and the frequencies are going to be, let's see, we'll mark by 2. So 0, 2, 4, 6, 8, 10, 12. And then since this is a continuous variable, we're going to make rectangles that touch each other. So that would be the rectangle of height 1. The next one has a rectangle of height 8. And you see how I'm going, I'm extending the rectangles to touch each other. And each one of the borders for the rectangles is a marked value. And the next one is going to be 9. So there's 9. And the next one's going to be 11. Next one's going to be 9. And then 3. And then 3. And so now I can just complete this picture here. It's going to look like that. Okay? Alright, so that was B. And then for C, what is the modal class? Remember, the modal class is easy to see because it's going to be the highest column. So it's that one, 185 to 190. So let's see, I'm going to put that modal class is a 175 less than or equal to h is less than 180. And it says, explain what that means. It is the interval which contains the most people with that height. The frequency is the highest, basically. Describe the distribution of the data. Here they want you to say if it's positively skewed or negatively skewed. And if you kind of look at the shape, it looks like it's pulling more to the right, so we'll say it's positively skewed. Okay? And that's it for number 1. That was easy, right? Number 2. A school has conducted a survey of 60 students to investigate the time it takes for them to travel to school. The following data gives the travel time to the nearest minute. Is travel time a discrete or continuous variable? Well, this one's kind of tricky because, you know, time is usually a continuous variable, except in this case, all the numbers somehow are whole numbers. So they've kind of rounded everything. So, you know, in this case, time is a discrete value, but you know, usually when you measure time in an experiment, it's a continuous variable. Okay, copy and complete the frequency table shown. Describe the distribution of the data and what is the traveling time modal class. So I'm going to count a few here just to show you how to do it, but then after that I'm going to finish it offline because it's going to be really boring to watch me do this. So 12 would go there, 15 would go there, 16 would go there, 8 goes there, and then I'm going to pause this so that you don't have to watch me do all this painful counting. Okay, I counted up all the different numbers, and I got 6, 26, 13, 10, and 5. Describe the distribution of the data. Well, if I don't even have to graph it out, I can already see that it's kind of dragging out to the right, right? The peak is here at 10 to 19, but you see the data drags to the right. So I'm going to say that it's positively skewed. Positively skewed. Okay. And then what is the traveling time modal class? So that's really easy to identify because the modal class is the highest peak. So that would be 26, right? or not 20. I'm sorry, it's not 26. A lot of people make that mistake on the test, by the way. You should put the name of the class, which is 10 to 19. Okay, 10 to 19. Okay, last one. For the following data, state whether a frequency histogram or a column graph should be used and draw the appropriate graph. We've basically got data here that is whole number data. If you look at the top row, that is the values, and the bottom row is the frequencies. You need to look at the top row. So the top row has whole numbers here. The top row here has like intervals or ranges, and you can read the type of data here. You have number of matches, which is going to be whole numbers, and then you have heights, which is going to be like decimal numbers, which is why they made intervals instead of just putting numbers here. So when you have this, you're going to want to use column graphs because it's whole numbers, separate little columns with space in between. For this one, you're going to use columns or bars that are like stuck together. So let's draw the x-axis for each one. So for the first one, we're going to have something like this. Each one of these space intervals here is going to be a number. So let's start with like 47. Let's zoom in a little bit. It's really hard to write 47 in this little space. 47, 48, 49, 50, 51, 52, 53, 54, 55. Is that how far we're going? 55? Yeah, I think 55 is the highest. Okay, and then each one of these is going to have a column, which is not going to touch the neighboring column. This is going to be 2, 4, 6, 8, 10, 12. This is 12, this is 6, 2, etc. And so I'm going to draw the columns. So 47 is going to be height 1, so it's going to be halfway up there. 49 is going to be height 1, it's going to be halfway also. 50 is going to be height 9, so it goes all the way up to there, right? 51 is going to be height 12. And on the test, of course, you're going to use rulers to do anything like this that involves straight lines. And they might take off for it too, so please don't lose points for something silly like that. 52 goes up to 4. And 53 goes up to 2, and 54 has 0, and 55 goes up to 1. So the first graph looks like that. That's A, and we could put number of matches, and then here we put frequency. Okay, and then in the other box we're going to put ranges, and the ranges go right on these lines here. So it's going to be 120 to 130 to 140, 150, 160, 170, and then each one of these is going to be, let's see, I'll count these by 5s. So I'll have 5, 10, 15, and this would be height in centimeters, and this would be frequency, and the first box is going to go up to number 1, next box is going to go to 2, next box is going to go to 7. Next box is going to go to 14. The next box is going to go to 1. Okay, so do you see how these columns are all stuck together, and the numbers are aligned with each of the vertical lines as opposed to the column graph, which we see over here. The columns are separate and the numbers are underneath the column. That's it.